We've been camping out with SQL operators in the past few lessons. We have discussed the arithmetic operators, the comparison operators, and lately the logical operators. These operators have allowed us to increase our T-SQL vocabulary, thereby giving us the skills to write queries that answers more involved and simple to complex queries systematically. Today, we will wrap up our discussions on operators for now by looking at a couple more operators that will allow us to hone our database programming skills. Let's get it done. In our discussion about filtering data, we have been introduced to writing predicates using comparison operators. These operators were exact, that is, if you are asked to return employees who are located in London, you are likely to write a predicate using the equal to comparison operator to compare the city column of the employees table to exactly the literal string London, like this. What you just did here is an exact match of the literal string London to the values in the city column. What happens when you must filter character strings but don't have the exact match? That's what we will be considering as we expand our knowledge of querying string data. Before you think, in what situation won't we be matching exact literal values? I'll demonstrate with an example. Your task is to retrieve product data for a product with the name Chef Anton's Gumbo Mix. I'll bet that by now, your query design will yield a query like the one we have here. Before I progress with the discussion on matching exact string characters, let me point your attention to the literal string in the predicate. Notice how I use two single quotes in the Anton's part of Chef Anton's Gumbo Mix. This is because the literal string I am trying to find contains an apostrophe, which happens to be the same character I am using to delimit the entire string. So the database engine does not misinterpret the apostrophe, which I definitely want to display for a delimiter. I had to escape the apostrophe with another single quote within the literal string. We will have more opportunities to discuss escaping special characters as we deal with string manipulation. I pointed them out here because this is the first time we are seeing this in our course. Let's return to our query. If you run the query above, it will give you a record showing the product details of Chef Anton's Gumbo Mix because you have given your predicate an exact match of the literal string we were searching for. What if, when your manager handed you this task, all she said was that she needed the details of a particular product and all she can remember is that the name contained the word gumbo somewhere in it? You can't write the query as such. This won't return any row from the product table because the requirement wasn't that you needed to return the product with the name Gumbo. It was that the product name you are looking for had the word Gumbo somewhere in it. You are not looking for an exact match, you are looking for a pattern. In SQL, whenever you are filtering character string data and you need to look for a pattern, you cannot use the comparison operators to write your predicate. You have to use the like predicate instead. The syntax of the like predicate generally goes like this: the column, the like keyword, and the pattern you are looking for. The like predicate supports wildcards that you can use in your patterns. You have seen a wildcard before, the asterisk wildcard in your select clause as a shortcut to return all the columns in a table instead of typing each column name. Wildcards are placeholders used to replace or represent one or more characters. Let's look at the wildcards available to the like predicate and their meaning. Then rewrite our gumbo query to return what the query requirement specifies. Because an example is the best way to demonstrate usage and meaning in programming, we will return to our gumbo task. Look at the like predicate and the wildcards above as tools available to you when you need to write predicates where patterns as opposed to exact match is needed in the where clause. Remember, the requirement of the task at hand is to write a query with the product details of a product with gumbo somewhere in its name. Using the like predicate, our query becomes immediately you realize that where you previously had the equals to comparison operator, you now have the like operator followed by the string literal gumbo, but now wrapped between two percent signs. From the diagram, you know that the percent sign wildcard matches any string of 0 or more characters. Therefore, what your pattern is saying in this like predicate is match any strings of one or more character before the word gumbo and match any string of one or more characters after the word gumbo. This is what the requirements specify. So let's run the query and review the result. The result shows the product we are looking for with its detail. Bravo, your supervisor is proud that you saved the day. How about we write a query that will return products whose name starts with the letter T? We know we can't use the comparison operator to write our predicates because we are not looking for an exact match. Therefore, we will use the like predicate. But which wildcard should we use? In this case, we are looking for any product that starts with T, with any 0 or more characters following. The percent sign wildcard does just that. This means our like predicate in the where clause would look like. When we run this code, 6 products match this criteria. How about if we were asked to search for an employee whose last name starts with P, but the second letter of the last name can be any letter from the letter A to E, and it doesn't matter what the combination of letters after that is. Here, our pattern is a bit more involved. First, we know the first letter of the last name starts with P. That's straightforward. Second, the second letter should be between A and E. And third, the rest doesn't matter. The first part of our like predicate is covered. We simply start with the string character P. We also already know the percent wildcard represents one or more characters. Therefore, the third part is also covered. We use the percent wildcard. What about the second part? Well, we have wildcard that tests for a character list. Does this mean we will need to combine wildcard? Can we do that? Yes, we can. Notice how we structured our pattern in the like predicate. We started with the character P in the first position, and right after that, we added a pattern that will test the second position to see if it's characters A to E. Right after the second position in the last name, the percent wildcard returns any number of characters. Running this gives us the last name Peacock when we run the code. Try your hands on the following 5 exercises. These exercises target the Northwind database. Next, let's look at a situation where we need predicates that test ranges and lists. Assume you were asked to write a query that returned the data for product IDs 10 to 15 from the Northwinds product table. While designing your query, you realize you need to include product ID 10 or product ID 11 or product ID 12 or product ID 13 or product ID 14 or product ID 15 in your query. So you use the logical OR operator to write the query like this. If you run this query, it will return the product data you are looking for. But the problem with writing query like this is that it is very inefficient. Not only that, I want you to think back to when we discussed the concept of writing programs that scale with added complexity in the beginning of our class. If we revised the requirement to include product IDs 10 to 200, how long can your logical OR statement grow? This means our query in this form will not scale. Okay, you realize that the above query is both inefficient and would not scale. And back to the drawing board or design board to be more specific you go. You realize at this stage that the product IDs requested 10 to 15 is a range, and therefore you could use the comparison operators greater than or equal to and less than or equal to test this range. Therefore, your query in version 2 looks like. There is actually a lot more improvement from the first version of your query, because not only does it use just 2 predicates, it also scales well, and if you run the query, it returns the rows you need. Like I said earlier, the product IDs you are interested in is a range between 10 and 15. Whenever you need to retrieve a range in SQL, you can write your predicate using the between logical operator. Let's see how this works. This means that with the between operator, we can further simplify our filter clause to have a single predicate. Run the code to verify it still returns the correct range of product IDs. Before we discuss between operator in depth, I want to make a couple of points with regards to writing programs in general based on what we just did above. The first is start with what you know. Don't wait until you have the perfect solution before attempting to solve a problem. In our case, even though our first attempt was inefficient, but it was a good place to start, even if to just get those creative juices flowing. Secondly, refine your code as you learn more. Remember our discussion on refactoring. Computer programs are rarely one and done. Things change, our knowledge of the business domain and or problem improves. We should incorporate those improvements into our programs as well. Now back to between. As you have seen, the between operator specifies a range to test. It is used in predicates in the where clause to retrieve rows that are within a specified range of values. SQL Server includes the end values in the result set. In our example, 10 and 15 are the end values of the range and are returned as part of the result. Therefore, anywhere you have the expression where something is greater than or equal to x and less than or equal to y, you can always simplify this expression with a between operator. In situations where you do not want to include the end values, you will have to use your comparison operators with the logical AND operator, as we did in the second version of our query above. What if instead of a range of values, you had a list? You are asked to write a query to return data for product IDs 1, 7, 10, 70. This is definitely not a range of values, so between won't work. But we could slap logical ORs as predicates like we did in version 1. This is a good first start. Crafty programmers would even call this quick and dirty way to view data when they don't want to be bothered. But we already know that while we return the data needed, This is neither efficient nor will it scale. Fortunately, SQL has another operator that is useful in testing a list of values. It is the in operator. We will use the in operator to rewrite the above query and discuss it on the other side. As you see, the syntax of the in operator is the column, the keyword in, and then a comma-separated list of values in parentheses. So our predicate for the above query becomes product ID in 1, 7, 10, 70, all in parentheses. Run the query to see the list of products returned. If you are given a few more products ID to return, simply add it to your list, making sure it is comma separated. You could also search through a list of character values. Say you were asked to retrieve a query that returns suppliers in either Spain or Italy. This is a list of countries, so it is a good fit for the in operator. Notice that the country data value we are interested in as character strings. Therefore, they are delimited with single quotes in our comma-separated list in the parentheses of the in operator. We have seen that the in operator determines whether a specified value matches any value in a list. You use the in operator in the search condition of a where clause to retrieve rows that match a specified list of values. If the value of the text expression is equal to any expression from the comma-separated list, the result value is true. Otherwise, it is false. You can use the in search condition anywhere you can use the logical OR operator. SQL Server resolves them in the same way, returning identical result set. Go ahead and run your query to see that it returns the rows you asked for. Using the NotWin database, try your hands on the following queries. Now we know how to use the like operator to test patterns. Then we talked about the between operator and the in operator to test ranges and lists. Let's continue writing queries that will help us solidify our knowledge of everything we are learning to program databases. In the next class, we'll be talking about sorting data. See you then. Thank you.